All right, this video we're going to start talking about mirrors forming images rather than uh, lenses. So for a mirror, they bend light through reflection. Okay, and just like lenses, we're going to have two different types. We're going to have a concave mirror. So here's a concave mirror, and it looks like the light's going into the cave. And then this over here is the back side. And on this side, the front side of the mirror bends out, so that's convex. And the concave mirror is going to be converging. And that's the reverse for what happened with lenses. The converging lens was the convex lens. The converging mirror is the concave mirror. But then this is going to act just like the convex lens did. Okay, parallel light gets reflected to the focus. So that's what you're seeing here, the light that's coming in here. It's all coming in parallel, all is going through that focus. And an example of this is a satellite dish, okay? The antenna is actually placed out here, okay? But you have this ditch to collect more of the radio waves coming in. So the waves are coming in like this, and they all get reflected down into here. Now, just like a convex lens, since this is converging, it can form images which are and this can make real or virtual, upright or inverted, and magnified or shrunk. All right. Now, for the convex mirror, this is going to be our diverging mirror. Parallel light reflects away from the focus. So in this one, we have the focus back here. This parallel ray hits the mirror and bounces back this way. We have this dotted line going back here showing that it seems to have come from the focus. And that's true for all these rays. They all bounce away from the focus. These can only form images which are virtual, shrunk, and upright. Now, and the focus is negative for these when we do our math. Now, we're going to find that the math is exactly the same and the ray diagrams are the same. I'm not going to bother rewriting the equations, but for the ray diagrams, we're going to have a parallel light reflects through the focus, just like we had before. And we are going to have that. And we're going to have that light through the center just reflects through the center. Okay, so just like the lenses. And there's one thing we need to know is where is the center? The center is at 2F. So that's going to be a little bit different. Okay, the center for a lens is in the middle of the lens, but the center for a mirror is at 2F. And what that's saying is this: if this is my mirror here, if you consider this as part of a whole circle, all right, the center of that circle is going to be right here at 2f. So moving on to some examples. All right. So I have an object here, and it's 6 from the mirror. You always measure everything from the mirror or from the lens. The radius is 4, it says. Well, at the end of the radius is the center. So that's telling me that the center is going to be at 4. So 1, 2, 3, 4. I'll put the center there. And then remember, that's equal to 2f. So f is going to be here. All right. And then I'm going to use my straight edge, and I'm going to go ahead and draw in my rays. So the first one's going to go parallel and then bounce down through the focus. So something like this. And I think what we're going to find is that these ray diagrams aren't quite as precise as they were for the lenses. It's because this curvature may not be exactly right. But anyway, parallel goes down through the focus. Second one goes through the center. And just goes straight, like so. And where they meet is where our image is going to be. So there is the image, because those two rays are meeting right here. And if I look at that, okay, the image is pointing downward, so it's inverted. It's shrunk a little bit because this one's 3 high and it looks like this one's just a little over 2 high. And it is real because the light actually gets to that point. Now again, the math is going to be exactly the same. So 1 over dO plus 1 over di is 1 over f. So the object's out here at 6, so 1 over 6 plus 1 over di is 1 over, and the focal length, again, everything measured from the mirror, is 2. So 1 over di is 1/2 minus 1/6 is 3/6 minus 1/6. So that's going to be 2/6. So then di is going to be the reciprocal of that, 6 over 2. So di is equal to 3. And if you look, like I said, these are a little bit off. It really should be over here at 3. You know, it's over by 2, so not too far off. And then Si over So is minus di over do. So Si over, this thing is 3 high, is minus, and di was 3, and do was 6. And we get Si is minus 1.5 centimeters. Now again, this diagram isn't exact. We got to be in about 2 or 3. It really only should be 1.5. Our next example. All right. Now, you may be starting to get used to this. When we start to bring the thing really close, we end up with the upright virtual image. So let's see if that's what's going to happen. So we got the 3 centimeter object, 3 centimeters from the mirror. The focal length is 4. So we'll put a focus here. And then it doesn't tell us where the center is, but we always know it's twice f. So if that's at 4, the center is going to be at 8. All right. Now, I draw in my 2 rays. I go parallel till I hit the mirror, which is just this little guy here. And then I go down to the focus, like so. And then one that goes through the center just goes straight. So like this. And we can see back here, they're never going to meet. When they're not going to meet, we extend them behind the mirror as dotted lines because the light never actually got behind the mirror. So we're going to dot these back this way. And back this way. They're going to meet back here somewhere. So there's my image, and it's pointing up away from the center line. And we can tell by our picture that the image is, it's upright, pointing up. it is magnified, and it is virtual because the light never got there. We had to extend the rays back to find it. Again, we'll do the math. 1 over dO plus 1 over di is 1 over f. Distance of the object from the mirror is 3 plus 1 over di, and the f was 4. So 1 over di is going to equal 1/4 minus 1/3. That's 3/12 minus 4/12. So 1 over di is minus 7. Oh, I'm sorry, minus 1/12. So di is minus 12. Now this one really didn't come close. The curvature of this mirror is not right. But we do have it being negative, which is promising because that's when you get a virtual image. And then Si over SO is minus di over dO. So Si over 3 is minus 12 over 4. And if I do my math right, I get Si is equal to positive 9 centimeters. All right, positive means pointing up, 9 meaning it's big. So even though the diagram is exactly right, this is verifying what we're seeing. And one last example, I believe, of a convex mirror. Here we go. So we have the convex mirror here. We got the object. It says the focal length is 3. 1, 2, 3. So we'll put the focus there. And the center is at twice the focus. Now for these, I'm going to draw the parallel line. Okay, and it's going to hit the mirror like so. But instead of going down through this focus, it's going to hit this mirror and bounce away from it. It can't go through the mirror to get to the focus, so it's going to go away from it. So like so. So the light physically does this, all right? And we're going to draw a dotted line back this way, showing where it appears the light came from. So if my eye is looking up here, I'm going to look back here, and I'm going to think that the light came from back there. Now the one through the center, we just go straight. What it's physically going to do is go from here, hit the mirror, and then bounce straight back out, okay? And we're going to dash the line this way, okay, showing that that's where the light appears to come from if I'm looking back along this line. So the light physically goes like this, bounces straight back out, and it looks like it came from back here. Here's where they meet. So I'm going to draw my image right here. And we can see, and this is going to be always true for these convex lenses, that the image is, or convex mirrors, it is shrunk, upright, and virtual. When we do our math, remember for a convex mirror that's diverging, which means F is negative, so we'll do 1 over dO plus 1 over di is 1 over F. So 1 over 1, 2, 3, 4, 5, 6, 7, 8 plus 1 over di is 1 over minus 3. Got to remember to make that focus negative. So 1 over di is going to be minus 1/3 minus 1/8. This is going to be pretty. It's going to be minus 8/24 minus 3/24. So 1 over di is minus 11/24. So di is going to be minus 24 over 11. Which is just going to be slightly over 2. And it turns out to be minus 2.18. And if I look at this, well, look, here's -1, there's -2, so it's just past -2, so we're matching up pretty well. And SI over SO is minus DI over DO. SI over my object is 3 tall is minus, I'm going to leave this as a fraction this time, and then DO was 8. So SI, and if I do my math right, the 8 will go into here, so that's going to be 9, positive 9, and then multiply, so it's going to be, or 3 times 3 is 9/11. So just a little bit less than 1, and if I look here, it's a little bit less than 1.